For logs, that's also something you want to look into. I mentioned you can log a collection. You can also log global, so you log the whole MongoDB instance, or you only log one single database in MongoDB. So there are three levels of logging. In general, you will not use that, but there are some reasons why MongoDB would be doing that. You can get them by the service status logs, and then you can see the various logs. So you have the global log, where you try to acquire one, a log, the weight count, and I've cut off all the other underneath here of database and collection logs. And you can see whether it's a read-write log, and there are also exclusive logs. Now, in WireTiger, it's the storage engine that actually handles document level logging. So that's on a different level than the MongoDB level logs. The WireTiger logs is not something you can enforce yourself. So the document level logging will happen by WireTiger internally. WireTiger basically allows you to do a similar thing to threading in MySQL. So whenever you write a piece of data, it's going to do that with one single thread. If there's another thread trying to do that, it will just create a ticket to tell that thread to wait. Those tickets are reflected in read and write tickets, and you can fetch them by the WireTiger current connection concurrent transactions, and then you can see whether you have write out, which is the number of current tickets being handled, and then you have the current available. So if the number of available tickets is getting really low, then there's something going on in WireTiger, and you have, for instance, a hotspot within one single document, and there are a lot of tickets handed out to, for instance, the write operations, and if someone wants to read the same piece of data, it has to wait as well. So this is also something you really want to be aware of. For cache, cache is similar to MySQL. You have similar types of cache. You have the file system cache, active memory. So that's the memory that's MongoDB using. So you do not have anything like the query cache in MySQL that is actually one piece of configurable cache. MongoDB handles everything itself, so it's using its memory for all sorts of purposes, like the sort buffer, or in this case, the query cache itself. Then you have the storage engine cache, like WireTiger and MongoRocks, and those are the three tiers of cache. Once you are requesting data from MongoDB that's not inside the cache of that node, it will give a page fault. And those page faults are counted for. And so you will know that there's a cache miss. Also, whenever there is memory in the active memory or in the storage engine available, and there will be evictions happening of that cached item. So if you want to get the number of page faults, that's quite easy by getting the extra info page faults, and that's just the number of cache misses. And for WireTiger, you can get the cache statistics by the WireTiger.cache. And I've only condensed it to the four most important ones. The number of bytes currently in the cache, so you will know whether the cache is currently full or not, whether it's using everything. The tracked dirty pages in the cache is also important to keep an eye on. Those are basically pieces of data that have been modified but not yet written to the journals. So if this number increases a lot, that means that your journaling will start lagging behind. We have the modified pages affected and the unmodified pages affected. So that's the eviction of the eviction rate of data. If you have a lot of unmodified pages affected, that means that you probably can cache data better by using an external cache, because, well, basically it's never going to be requested from MongoDB anyway. And if you have a lot of modified pages affected, that means that you're modifying a data a lot, but you're never reading it back. So you probably have a really high write load in MongoDB and never going to read it back. Some available open source MongoDB monitoring tools will cover that. So we have alerting solutions. We mentioned Nagios and Zabbix already. We've seen that it's quite popular, both of them. But there are also a couple of subscription-based, and we have the MongoDB Cloud Manager, or the Mongo Ops Manager as it used to be called, which is a paid service. We have Vivid Cortex offering you installing an agent on your MongoDB cluster and then looking at it. And we have ClusterControl, our own product, that gives you a subscription-based alerting solution. For Nagios, there's a really nice Nagios plugin. It's performing the most important checks like replication lag, the log time percentage, and the index miss ratio. So it's really good that it keeps an eye on all these different aspects of MongoDB. So it's quite a broad tool for that. And for Zabbix, we have another really nice plugin that measures everything inside the oplog and all the necessary metrics that you need. It also can do pre-can triggers, so you can put triggers on certain metrics that it is collecting, so you can modify it yourself quite easily. For training solutions, there's StatsD Grafana, so you ship your MongoDB metrics from using StatsD to Grafana. We have Cacti, we have Zabbix, and then we have the same subscription-based MongoDB Cloud Manager, Vivid Cortex, and ClusterControl. For Cacti, we have really nice Percona MongoDB monitoring templates, and those monitoring templates are similar to the MySQL monitoring templates, and they have really nice graphs that give you good insight in what is happening. And then there is a new system called the Percona Monitoring and Management. It's still in beta at this moment. It uses in the background Prometheus and Grafana to do monitoring. But in addition, it can also deploy and manage your MySQL and MongoDB nodes. However, as I mentioned, it's still in beta, so it's not something you should use in production yet. Now, how can you monitor MongoDB using ClusterControl? Well, it's quite easy. We offer an orchestration system, ClusterControl, that allows you to deploy Mongo shards replica sets. It also allows you to monitor and trend and manage the configuration, backups, and scale. And we also offer a community edition that allows you to use our software to deploy and monitor. And also, the community edition is a 30-day trial for enterprise features as well. And after 30 days, those enterprise features will be switched off. So deploying a MongoDB replica set and shard is relatively easy. We have a really nice wizard that just guides you through 4 simple steps for the MongoDB shard. For replica sets, it's only 2 steps. And it's relatively easy to add new nodes and configure it. For monitoring and trending, we offer a really nice dashboard, and we have node-specific host information. For management, we offer backups, configuration management, and also shipping your backups. And then for scaling, we allow you to add new nodes to replica sets. So it's relatively easy to scale out a replica set if necessary. And it's time for a demo, so I have to switch windows at the moment. Let's see if I can focus on the screen only. Okay. So in ClusterControl, we have the overview of our clusters active here, and we can see that we have one MongoDB replica set active with a lot of instances. We can immediately spot that there are some issues happening in the MongoDB cluster, so we know we have something to look for. We can click on it and immediately go to the node information itself. So that's one of the nice features of MongoDB. And then we can try to figure out what is going wrong with this node. We can try to start the node again, restart it, or reboot the host if necessary. Going back one step to the overview. In the overview, we offer a really nice overview of the, in this case, the cluster. So we have a sharded cluster. We have one shard here. It's the shard servers grouped together. We also have the config servers grouped together. And you can see that actually the issue happening here is with the config servers. And then we have the Mongo's server. So you can see in one glance that those are still fine. You can also see that the ping times are relatively okay. So suppose you have a high ping time here of a couple of seconds, then probably this node wouldn't be elected as the next primary. Suppose I want to zoom into what is happening here. I can just click on whatever we have here and then see with a fine granularity of at most 5 seconds what is happening in our cluster. So we offer a fine-grained view. We also have a couple of dashboards that are pre-populated with data. So for instance, network, the wire tiger cache, which is important to keep an eye on. We can zoom out to, for instance, 1 day of data, and then you can see clearly that we started writing here to our cluster, and then zoom into that and then see even with finer granularity what is happening here, why is it happening. So it gives you a really, really good tool to zoom into issues in your cluster. I briefly showed you the nodes overview. Within the nodes, you can see CPU usage, network usage, disk space, RAM, and this is basically what you can use to look at capacity planning or relate this to any issues happening in your MongoDB cluster. With the Ops Monitor, we can see all the current running processes in MongoDB, so you don't have to log into each and every node in MongoDB. Everything that is currently running in your cluster will be put together here, an aggregated overview. So no need to log in to 6 separate nodes at the same time. For performance, we have the MongoStats, which is, if you're familiar with that, you can see the query performance of the things happening in your cluster right now. We have, similar to the dashboards, all the performance ops counters here. And we have advisors, and the advisors will give you a good insight in what you should do or maybe should improve into your system. Once we think something is going wrong. We have, for instance, high CPU usage on one node, so we give a warning. We have swappiness not being set correctly, so we need to adjust that. So it's giving us friendly advice. For MongoDB, we have a couple of ones that are checking the number of connections coming in, so we can see whether the number of connections isn't spiking often. We can see whether the percentage of used tickets is satisfactory. So if we have a lot of locking happening, we will probably see a warning here. And the same for replication lag. We can see that in one glance here, but the replication is functioning fine. This is what we offer for MongoDB monitoring. As I mentioned in the presentation, we have a couple of additional functionality like backups, managing of configuration, setting of alarms, and you can look at, for instance, MongoDB system logs here, and the whatever is here for Seaman. And that's it. Let's go back to the presentation.